This is 2.8, composition of functions, day 1. First, we're going to start with a warm-up of finding the domain of this rational function. Remember, when you see find the domain, it's asking what numbers are okay. Sometimes it's easier to think about it in reverse, though. What numbers are not okay? And this is one of those times where I think thinking about it in reverse makes more sense. Because in a fraction, you cannot have a 0 in your denominator. So if I think about what I can't have and figure out what that number might be, then it can help me figure out what I can have, because domain is what numbers are okay, but sometimes it's easier to think about what numbers are not okay first, leaving all the rest that are okay. So how I'm going to start this is I know that this denominator cannot be equal to 0. So I'm just going to take the denominator only. The numerator doesn't matter. It could be anything up there. And I'm going to solve this. So x squared cannot equal 9 if I added 9 to both sides. If I take the square root, x could not equal, most of you know the square root of 9 is 3. What some people forget, that it's also a negative 3. So x cannot equal positive or negative 3. So visually, what this is saying is on your number line, x can be any number, but it cannot be negative 3, and it cannot be positive 3. So it can be anything to the left, anything in between, and anything to the right, but it cannot be those two numbers. So when it asks us to find the domain, it almost always wants us to put it in interval notation. So how do we write this in interval notation, excluding negative 3 and 3? Well, we just do 3 separate pieces, 3 different intervals. So negative infinity all the way to negative 3. Then in between, negative 3 to 3. And then 3 to infinity. All right, so today we're going to be talking about composition of functions, and we're going to be using the same functions over and over again. So please make sure you write these functions down, because we're going to be using them throughout this lesson and actually our next lesson as well. The first thing that we want to see is that we have 3 differently named functions, f of x, g of x, and h of x. So when we go and start having the questions, it's going to refer to 2 of those 3. So this first one, find f plus g of x, then state the domain. When it's written like this, it's no different than saying f of x plus g of x. So we're going to take the function f of x, which is x squared plus 6, and we're going to add it to the function g of x, which is 3x squared minus 2x. All we do from there is combine our like terms. So we combine those x squareds together. X squared plus 3x squared is 4x squared. There's not another x, so it just stays as negative 2x plus 6. Now notice I wrote it in standard form. So the biggest degree is first, and then the next, and then the last. So f plus g of x, this is our answer for that part. And then it says state the domain. So remember, domain from our warm-up means all the numbers that are okay for x. Well, this is a quadratic, and you can put any value in for x in a quadratic. So there's nothing excluded here. So our domain is negative infinity to infinity. So all numbers are okay. All right. Let's try this one, g minus h. So hit pause, give that a try, now that we talked through that last one, and see if you can figure out what g minus h of x would be. So we're going to take our g function, 3x squared minus 2x, and we're going to subtract the h function. Now here's where some people make a mistake. We have to subtract the whole h function up here, 4x plus 7. So we have to subtract the 4x, but we also have to subtract the 7. And some people only put the subtraction sign before the 4x. So make sure you're subtracting the whole thing. Then just like last time, we have to combine like terms. So we have 3x squared minus 6x minus 7. All right, then state the domain. Again, this is just a quadratic. Quadratics are okay with all numbers. They don't have any exclusions. So negative infinity to positive infinity. All right. Next up, we want to find f times h of x, then state the domain. So our f of x is x squared plus 6. Our h of x is 4x plus 7. And we want to multiply that, so we're going to FOIL. X squared times 4x, 4x cubed, x squared times 7, 7x squared, plus 24x, plus 42. Then we want to state the domain. This is a cubic. If you remember, cubics look like John Travolta. And they don't have any restrictions on the domain. Gotten lucky on all these. So our domain is negative infinity to infinity. All right, next one. Find g divided by h of x. So we're going to take our g of x function, which is 3x squared minus 2x, over 4x plus 7. If you remember when we studied rationals, we always want to have everything as factored as possible. So if we look at our numerator, we can see a GCF of x that we want to take out. Our denominator doesn't factor at all. And we cannot simplify these x's because of this plus sign here. So we just leave it factored like that, but we can't simplify anything on this particular one. But then we need to state the domain. Now this is a very different function. This is a rational function like we did in the warm-up. So just like the one we did in the warm-up, we know that our denominator cannot equal 0. So this is our answer, but this denominator here is not allowed to equal 0. So if we solve that, 4x plus 7 is not equal to 0. We subtract 7 to the other side, and then divide by 4, we find out that x cannot equal negative 7/4. So when we go to write the domain, we can have all numbers that are possible except for negative 7/4. So we can do negative infinity all the way to negative 7/4, and then skip over negative 7/4, which we show by a parenthesis, and go negative 7/4 to infinity, just like we did in our warm-up today. All right, so here's another division one. Go ahead and try it. It's similar to number 4. See if you can figure out what our domain should be after you divide, and then come back and check and see if you've got it right. All right, so f divided by g, x squared plus 6 over 3x squared minus 2x. We first want to try to factor. The numerator does not factor. The denominator has a GCF of x. And then can we reduce anything? No. So this is our function, but it's a rational again. So rationals can't have x in the denominator. I'm sorry, can't have 0 in the denominator. So this denominator cannot equal 0. Well, this is already factored for us, which is nice because that means we can set each factor equal to 0 or not equal to. So this tells us x can't equal 0. And if we solve this, we also find out that x cannot equal 2/3. So there's two numbers that x can't equal. Okay, so visually, again, we can do that number line. We have 0 and 2/3 on our number line. X cannot be either one of those, but it can be anything to the left, anything in the middle, and anything to the right. So when we write our domain, we want to describe all three of those pieces. Negative infinity to 0, 0 to 2/3, and 2/3 to infinity.